So let's take the next sum. Calculate compound interest on rupees 8,000 at 10% PA for 1.5 years if interest is compounded half yearly. So, you know, all the sums that we had done till now, most of them were done on annual basis, per annum, if you remember. So they were all done in yearly basis. This sum essentially, the calculation has been done for 1.5 years and the interest rate is compounded half yearly. So there are two ways of taking this. One you can do is you can just plain use the formula, and what you do is the formula, the basic system of the formula remains the same. What I essentially do is, since the interest rates are being compounded half yearly, so instead of writing R, we do it R by 2. So it's like the rate of interest is essentially being halved. So that's R by 2. And what I do is, since I have replaced R with R by 2, the time period gets doubled. So the essence of the formula remains the same. I just make, based on the sum that has been given to me, I replace R with R by 2, and the time period, since I replaced R with R by 2, so there's a half pattern going on. I double the time period from n to 2n. So that's the basic formula that I have. So here, this represents the length of the time period under consideration. Had it been n, we could have written R. Since there's an R by 2 concept going on, we, instead of putting it n, we put it 2n. So that is why I'm using n and not t, because there's a time period going on. It's not exactly the number of years as such. So what I do here is I replace P, the principal, with 8,000, and instead of R, I put the rate of interest 10% as given in the sum for 1.5 years. So N, that's essentially 1.5 years. So that can give me 3 by 2. 1.5 years is actually 1.5. So that's 3 by 2 years. Another thing is, if you notice, the investment plan is going on for 1.5 years and the interests are being compounded half yearly. So if you cancel out 2 on the numerator and denominator from the exponent, you see I am left with 3. Now look at it this way. Let's say this is the time period under consideration. So this represents 1.5 years. So this entire portion is 1.5 years. Let me divide this entire 1.5 years length into 3 segments. So if this is 1.5 years, this is essentially half a year, this is half a year, and this is the third half of the year. So that's half plus half, that's 1 and 1.5 years. So this entire length gives me 1.5 years. And the interests are being compounded half yearly. So the interests are being compounded in this portion, and this portion. So they are being interested every half year. So you see, if the interests are compounded half yearly, then in 1.5 years, I have compounded the interest a total of 3 times. Because in 1.5 years, there are 3 halves of a year. That is, I have compounded a total of 3 times in this 1.5 years. So that kind of ties in with the concept of having 3 on the exponent. So that's an interesting note that we have, an interesting observation as such. So after that, it's just plain old mathematics. 8,000 into 1 plus 5 by 100 raised to the power 3. So you just do the basic calculations and it turns out to be 9261. So the calculation is not difficult. In fact, it's quite a very simple, straightforward sum. What we need to pay attention to is the formula that we are considering and the numbers and the values that we put. So that's an interesting sum. Next sum that we'll be taking into account, if you are a student who's interested in mathematics, you might have heard of this person, Keshav Chandra Nag. His sums are actually more popular because they say K.C. Nag's sums are a little more advanced, a little more developed than the other sums. So for those of you who are interested in the subject of mathematics, I just chose a random, I don't even know if it's a very difficult sum or not, but I just chose a random sum and I trying to solve the sum for you. So the sum says, a man borrowed a certain amount of money at the rate of 3% PA, so at the rate of 3% per annum or per year, simple interest. So up until now, this sum is going in the direction of simple interest. So let's just mark it. That's one half of the sum done. So the man borrowed a certain amount of money. So let's say the man borrowed some P amount of money at 3% per year simple interest. So it's being calculated simple interest wise. Next, what the man does is the man lent the same amount. So whatever amount he borrowed, whatever P amount principal he borrowed, he lent the same amount at 5% PA. So he is increasing the sum, increasing the rate of interest from 3% to 5%. Not only that, from SI, he's converted his own lending scheme to CI. So he had borrowed the amount of money at 3% per annum, a lower interest rate, and SI. And what he is trying to do is he is trying to earn an amount of profit by increasing the rate of interest to 5%, as well as by imposing a compound interest format of accruing interest rate. So we know if the interest rate increases, the total interest collected increases, and we know compound interest yields more interest than simple interest. So he's a greedy man, we know. So moving on with the sum, we see at the end of 3 years, he made a profit, which was obvious that he would make a profit of rupees 541. Find the principal. So we essentially need to find out the amount of money that he essentially borrowed. So let's assume the unknown variable that we have to be P. And what he did is at the end of 3 years, so the time period under consideration is 3 years. What we'll do here is we'll take costs and benefits into account. So the cost will be when he is acting as the creditor. No, when he is acting as the debtor of loan. So when he is paying interest, that is the portion that we consider the simple interest. So that is the cost that he incurs. And when he acts as the creditor, when compound interest is coming into the picture, that is his benefit. That is the portion where he earns interest. So we'll be finding out the difference between his costs and benefits, which will be the profit, and we'll be equating it, and we'll try to find out the value of principal, the unknown variable that we have. So that's part one. Let's take part one of the sum. So the portion where he acts as a debtor, the portion where he essentially is giving out interest, the part where he is incurring costs. So SI accumulated after 3 years plus principal, that's the amount that the person, the man will pay, the amount that he loses, the amount or the cost that he incurs. So that's the simple interest plus principal. That's the amount that we know. The definition of amount is simple interest plus principal or principal plus simple interest. And we know by now that the formula for simple interest is P R T by 100. So since P is unknown, we replace R with 3% because when he was using the simple interest and he was taking loan, it did it on the basis of 3% per annum simple interest. So we replace R with 3, and the entire scheme is for 3 years. So we replace T with 3, and we get P into 3 into 3 by 100 plus the principal P. So that gives me 109 P by 100. So that's the amount that he pays. Next, what you do is the amount collected after 3 years through CI. So this part is his benefit. The previous part that we calculated was his cost, and now we are coming into his benefits. So naturally, even without doing the sum, we'll know that this part is greater because this is A, the interest rate is higher, it's 5% now. B, it's done in compound interest basis, so it'll yield me higher interests. So if you again remember, please don't get confused. Here we are not considering the interests, we are considering the amount. So here we had to add the principal with the simple interest, and in case of compound interest, the entire formula stands for the amount. So don't add or subtract P from this. This is the formula that we want. So that's P into 1 plus R by 100 times T. So this R is essentially 5 because when he was lending out, he did it at 5% PA. And the time period, again, the time period scheme of the time period was 3 years. So that's P into 1 plus 5 by 100 raised to the power 3. So if we do that, we get this big value. It's seemingly a big value. There's nothing to be done. And what I do is to make this sum a little bit more easy and manageable, what I do is I take the cost portion of the man as A and I take his benefit to be B. I should have taken his cost to C. Well, doesn't matter. A comes out before B. So his profit will be his benefit minus his cost. So it's B minus A. So what we do is we subtract the first portion, 109p by 100, and we subtract this portion from this portion. So you see, P, if I take P common, I get 105 into 105 into 105 by, in the denominator, we have 100 times 100 times 100 minus the portion that he incurred as cost. So that's 109 by 100. And if you do the calculations, you get 0.067625p. So that's the profit that he earned. And they said that the profit that he incurred at the end of 3 years is rupees 541. So we essentially can deduce from the sum that this amount, this P amount 0.067625p, the profit that we earn from the calculation should be equal to 541 as per the sum. So again, this is a very, very simple, straightforward equation in P. That is, if we divide 541 by 0.067625, we get P is 8,000. So that's essentially the sum. So what the man did was, the man took a loan of 8,000 at simple interest at 3% per annum. And what he did was he lent the same amount. So he again lent it out to somebody, the same amount, 8,000 at 5% per annum compound interest. So he increased the rate of interest from 3% to 5%, and he changed the simple interest to compound interest, but the principal amount 8,000 remains the same. So he took a loan of 8,000, he lent it out to some other man, the same amount 8,000, and he made a profit of 541 in 3 years. So that was a scheme that the man used to earn money. So you see, that's an interesting way of putting simple interest and compound interest together, merging them both into the picture.